Welcome back. In this video, we solve the Chapter 2 practice test on trigonometry. Pause before each problem if you want to try it first, then compare your work to the solution. Problem 1. Find each reference angle. For 125 degrees, the reference angle is 55 degrees. For 155 degrees, it is 25 degrees. For 205 degrees and 335 degrees, it is also 25 degrees. The different one is 125 degrees, so the answer is A. Problem 2. Check each angle. 35 degrees is already in quadrant 1, so its reference angle is 35 degrees, not 55. The other three all have a reference angle of 55 degrees. The answer is A. Problem 3. The angle 150 degrees is in quadrant 2, where cosine is negative. Its reference angle is 30 degrees. Since cosine 30 degrees is root 3 over 2, cosine 150 degrees is negative root 3 over 2. The answer is C. Problem 4. The diagram gives a known angle and a known opposite side, so use the sine law. Match each angle with the side across from it. The equation with sine theta over 34 equal to sine 28 degrees over 70 is the correct one. The answer is B. Problem 5. The ambiguous case happens when we have side-side angle information, especially when using the sine law. Choice C gives angle B, side A and side B, which is SSA. The answer is C. Problem 6. Cosine is x over r, so 2 over r equals 1 over root 10. That gives r equals 2 root 10. Now use r squared equals x squared plus y squared. 40 equals 4 plus b squared, so b squared is 36. Tangent is negative while x is positive, so b must be negative 6. Problem 7. Sketch the two bearings from Ross Bay. The angle between north 79 east and north 57 east is 22 degrees. With the 1.9 kilometer and 1.1 kilometer sides in the diagram, the cosine law gives the Ross Bay to Oak Bay distance as about 2.6 kilometers. Problem 8. This is side-side angle information, so there may be two triangles. Using the sine law, sine B over 16 equals sine 30 over 10, so sine B equals 0.8. That gives B as about 53 degrees, or 127 degrees. Therefore, two triangles can be drawn. Problem 8 continued. For the first triangle, B is 53 degrees, so C is 97 degrees, and the sine law gives C about 19.9. For the second triangle, B is 127 degrees, so C is 23 degrees, and C is about 7.8. Problem 9. Rudy and the two goalposts form an isosceles triangle with sides 20, 20, and 6. Use the cosine law to find the angle at Rudy. Cosine R equals 20 squared plus 20 squared minus 6 squared over 2 times 20 times 20. This gives R about 17 degrees. Problem 10. This is another SSA case. Use sine Q over 12 equals sine 56 over 10. Sine Q is about 0.995, so Q can be about 84 degrees or 96 degrees. That means there are two possible triangles. Problem 10 continued. If Q is 84 degrees, then R is 40 degrees, and the sine law gives R about 7.8 centimeters. If Q is 96 degrees, then R is 28 degrees, and R is about 5.7 centimeters. Problem 11. Start with triangle ABM, where all three sides are known. Use the cosine law to find angle AMB. Since BMC is a straight line, angle AMC is supplementary to that angle. Then use the cosine law again in triangle AMC. The result is AC equals about 5.2 centimeters. Problem 12, Part A. The fence, the board, and the ground form a triangle. Use the sine law with the 1.4 meter fence and the 2.0 meter board. The angle the board makes with the ground is about 44 degrees. Problem 12 continued. The angle at the top of the fence is 180 minus 80 minus 44, which is about 56 degrees. Then use sine law or cosine law to find the ground distance. The bottom of the board is about 1.7 meters from the base of the fence. Problem 13. To build all angles from a reference angle, use the quadrant rules. In quadrant 1, theta equals the reference angle. In quadrant 2, theta equals 180 minus the reference angle. In quadrant 3, theta equals 180 plus the reference angle. In quadrant 4, theta equals 360 minus the reference angle. Problem 14. The home to second diagonal of the square is 70 root 2, or about 99 feet. Since the mound is 50 feet from home along that diagonal, second base is about 49 feet from the mound. First base to the mound uses the cosine law with sides 70 and 50 and included angle 45 degrees, giving about 49.5 feet. So the distances are not the same. Problem 15. Use the sine law when the information includes a known angle and its opposite side, plus one more side or angle. Use the cosine law when you are given 3 sides, or 2 sides with the included angle. In short, sine law needs an opposite pair, cosine law handles SSS and SAS. Problem 16. For the patio triangle, use the angle sum and sine law to find the remaining measures, 38 degrees, 25 degrees, and 2.5 meters. For the shrubs triangle, the missing measures are 55 degrees, 2.7 meters, and 3.0 meters. The important habit is to keep each side matched with its opposite angle. Problem 17. Let x be the distance the beta group can walk. The distance between the groups is 6.2 kilometers when radio contact is lost. Use the cosine law. 6.2 squared equals 3.8 squared plus x squared minus 2 times 3.8 times x times cosine 129 degrees. Solving gives the positive distance x about 3.1 kilometers. That completes the Chapter 2 practice test. The big decision is whether the question is about reference angles, a sine law opposite pair, or a cosine law SSS or SAS triangle. Rework the ambiguous case questions until the 2 possible triangles feel natural.